Hello students, welcome to the lecture on information technology in the supply chain, and after this lecture we will be able to learn the following objectives. Understand the types of IT use in SCM, explain the IT framework, understand the customer relationship management CRM, discuss the internal supply chain management, define the supplier relationship management SRM, understand the transaction management, explain the future of IT. Let us first talk about the information technology in the supply chain. Today, companies are often not considered independent entities, but parts of multi-company, multi-echelon networks, that is, supply chains delivering goods and services to the final customer. Supply chain management SCM literature proposes that integrated control of these multi-company networks can provide significant benefits. The utilization of information technology IT in turn is considered an imperative requirement for managing these networks and has been associated with significant supply chain efficiency improvements. Let's talk about the types of IT used in SCM. The first type of IT use, transaction processing, stands for the use of IT for increasing the efficiency of repetitive information exchanges between supply chain partners. In this type of IT use, the exchange information is typically related to such tasks as order processing, billing, delivery verification, generating and sending dispatch advices, and producing order codes. The second type of IT use, supply chain planning and collaboration, represents the use of IT for sharing planning related with the intention of increasing the effectiveness of the supply chain. Finally, the third type of IT use in SCM refers to the monitoring of individual orders or shipments, which may consist of components or final products with the aim of coordinating their delivery or conveying timely information of their location. Drivers for IT use in SCM. The second construct, drivers for using IT in SCM, refers here to the reasons why IT is used in certain manner in SCM. Based on literature review, we expected that following drivers for the use IT in transaction processing, we further hypothesized that the volume of transactions acts as a driver for using IT for transaction processing. It was also assumed that supply chain coordination information is shared, especially in volatile, unpredictable, and logistically demanding business environments. Finally, we expected that tracking and coordination activities are performed in project-oriented businesses and in cases with in-transit delivery consolidation. Data analysis. The data was analyzed in two successive phases. First, within case analysis were performed to assess how and with what kind of partners each of the case companies utilizes IT in its SCM processes and to understand why they use the technology in that specific way. Hence, for each company, the types of IT use as well as the drivers for the identified ways of IT use were identified based on the interview and survey data. After analyzing each of the cases separately, the cases were compared with each other in order to identify potential patterns within and between companies utilizing IT in a specific manner. In this cross-case analysis, the companies using IT in a specific way with up or downstream partners were first compared with each other to identify commonalities between them regarding the drivers for using IT and the business environment. After this, these cases were compared with the companies not using IT in that specific manner to chart the potential differences in the business environments between the users and non-users. Results. In the within case analysis, the relationship between the two constructs, the types of IT use in SCM and the drivers for the use of IT in SCM was examined. After looking at each of the cases separately, the cases were compared with each other in order to identify potential patterns between them. This cross-case analysis revealed commonalities between the companies utilizing IT in a specific way regarding the drivers of IT use. As for the business environment characteristics, the number and age concentrations of supply chain partners as well as the role of the company in the supply chain seemed in some occasions to segregate companies utilizing IT in a specific way from the non-users. However, order penetration point, the level of product customization, number of products, and the level of internal IT integration did not, to our surprise, distinctly differ between the users and the non-users in any type of IT use. Transaction processing. Most of the case companies, 10 out of 16, A, C, D, G, H, I, J, K, L, N, used IT to process transactions with their suppliers. 8 of the case companies, B, C, E, F, I, K, M, P, in turn used IT to transaction processing with their customers. Only 3 of the companies, C, I, K, used IT for transaction processing towards both up and downstream of the supply chain. EDI, XML, or extranet solutions were typically used for the processing of orders and invoices in the companies. In some cases, IT was also used to process delivery verifications and dispatch advisors. The reasons for using IT for transaction processing were rather homogeneous between the companies. The companies aimed to reduce manual work associated with sales transactions, to reduce the related costs, and to increase their liability and speed of information transfer between companies. In most cases, the partners for the IT applications were selected based on the volume of transactions. However, several of the companies stressed that especially with lean IT solution. Supply chain planning and collaboration. The use of IT for supply chain planning and collaboration was more limited in our sample than the use of IT for transaction processing. This result supports the earlier findings on the sharing of planning information. Less than half of the companies, A, C, D, I, J, K, used IT for supply chain planning and collaboration with their suppliers, and 3 of these companies, A, C, I, applied IT for this purpose also with their customers. Furthermore, unlike assumed, unpredictable and logistically demanding environment did not stand out as a driver for this type of IT use among the case companies. Instead, an important commonality among most of the companies using IT for supply chain planning and collaboration was that they use the information. Instead, an important commonality among most of the companies using IT for supply chain planning and collaboration was that they use the information shared through the IT system for running a specific cross-organizational process. Order tracking and delivery coordination. 5 companies, H, I, K, M, P, in our sample utilize IT systems in order tracking and coordinating the progress of orders or deliveries or in providing this information. Of these, in case I order, specific status reports were updated manually into an extranet page if customers specifically requested it. In case M, the company provided delivery status information to its customers as a high-end logistics service provider. In cases H, K, and P, delivery status information is actively collected, disseminated, and utilized. In case K, the company offers delivery status information to its customers on project orders, enabling the customers to synchronize the project activities with the availability of the material. The case company P in turn utilizes the delivery status information of the main telecom components to ensure material availability before scheduling installation tasks. The tracking information is most comprehensively utilized in case H, where the company uses delivery status information to control in-transit consolidation of the components of the end product. The delivery status information is also used to ensure that the final customer shipment includes all the necessary sub-deliveries. As to business environment characteristics, the use of IT for order tracking and delivery coordination seemed to be associated with the customized nature of the offered products. Let's talk about IT framework. Information sharing refers to activities that distribute useful information among multiple entities, people, systems, or organizational units in an open environment. Sharing information should consider 4 questions: what to share, whom to share with, how to share, when to share. Better answering these questions can greatly improve information sharing results, avoiding overload or deficiency, reducing sharing cost, and being more responsive. To address those questions and achieve better information sharing results, we propose a framework called Information Supply Chain, or ISC. The ISC framework is based on studies of supply chain management, SCM, which has been widely used in management science. A supply chain fulfills its customers' demand by a network of companies, mainly including suppliers, manufacturers, and distributors. A supply chain has two primary targets: to balance demand and supply, and to improve efficiency and responsiveness. These are also the primary goals for sharing information. We therefore envision that the well-studied SCM framework can work for information sharing. Similar to a supply chain, an Information Supply Chain 1 ISC fulfills users' information requirements by a network of information sharing agents ISA that gather, interpret, and satisfy the requirements with proper information. Here we will talk about Customer Relationship Management, CRM. The CRM, Customer Relationship Management, is an information industry term for methodologies, software, and usually internet capabilities that help an enterprise manage customer relationships in an organized way. Customer Relationship Management key features. Operational CRM is the aspect of CRM dealing with the automation of customer-facing or front office processes. Since operational CRM involves the automation of customer-facing processes, it relies heavily on the use of computer technology to achieve its goals. Collaborative CRM is an approach to customer relationship management, CRM, in which the various departments of a company, such as sales, technical support, and marketing, share any information they collect from interactions with customers. Analytical CRM. Customer relationship management may be defined as a decision support system that is targeted to helping senior executives, marketing, sales, and customer support personnel to better understand and capitalize upon their customer needs, the company's interactions with the customer, and the customer buying cycle. Like the term business intelligence, this is a fairly new term with a myriad of definitions and a variety of products that support some of those defining aspects. The main thing is, what does your end user need to do? You really need to build your own definition of analytical CRM based upon the prioritized needs of the users or user groups that should most benefit from this process and the supporting technical systems. From this, you may begin evaluating systems, architectures, and tools that will answer those needs in a timely and cost-effective fashion. Let's talk about internal supply chain management. Supply chain management is the management of all processes or functions to satisfy a customer's order. The Department of Defense, DoD, operates the world's largest supply chain, spends more than $80 billion annually on logistics, and employs more than 1 million logistics personnel. DoD supply chain managers manage approximately 5 million consumable and repairable items that are procured from more than 1 lakh suppliers and distributed to more than 30,000 customers. However, the supply chain performance measures available to senior DoD managers are not adequate to measure the overall effectiveness of the DoD supply chain. They are not balanced across customer service, balanced performance measures. The Deputy Under-Secretary of Defense Logistics, DUSTL, tasked the Logistics Management Institute to propose a set of balanced measures that senior decision makers can use to monitor supply chain effectiveness. A perfect order is an order that meets the following standards: delivered complete, all items delivered in the quantities requested, delivered on time using the customer's definition of on-time delivery, including packing slips, bills of lading, and invoices to support the order, delivered in perfect condition and in the correct configuration to be used by the customer, faultlessly installed as applicable. Supplier management. Supplier management is a key aspect of supply chain planning. The base for an effective supply chain is managing operations by sourcing from the right suppliers. This sort of management has the following aspects: supplier onboarding and contract management, B2B integrations with the supplier, supplier relationship management, supply chain procurement management. Following are the areas of procurement management: order and accounts payable management, manual and system generated orders, leveraging electronic data interchange, EDI interface, and reconciliation of PO, invoice, and delivery receipts or vouchers. Vouchers. Ability to create vouchers when merchandise arrives at a warehouse or a store, or when transferred merchandise arrives from other stores. Shipping notifications. Generation of electronic advance shipping notices, ASNs, to notify respective stores. Supply chain, EDI operations support. EDI operations have become a commodity. However, they still form a very crucial aspect of supply chain operations. EDI solution provides in the following areas: operations support for custom EDI or standard tools such as Geographic Information System, GIS, creating maps and supplier onboarding supply chain, logistics warehouse management systems, order management, wave planning, workflow management, and yard and dock management, among others, reverse logistics, return merchandise authorization, and replacement tracking. Here we will discuss about supplier relationship management, SRM. Supplier relationship management is a comprehensive approach to managing an enterprise's interactions with the organizations that supply the goods and services it uses. The goal of supplier relationship management, SRM, is to streamline and make more effective the processes between an enterprise and its suppliers, just as customer relationship management, CRM, is intended to streamline and make more effective the processes between an enterprise and its customers. SRM includes both business practices and software and is a part of the information flow component of supply chain management, SCM. SRM practices create a common frame of reference to enable effective communication between an enterprise and suppliers who may use quite different business practices and technology. As a result, SRM increases the efficiency of processes associated with acquiring goods and services, managing inventory, and processing materials. The value of SRM. Dedicated technology can support and empower your supply chain transformation by facilitating improvements and driving efficiency across all your sourcing and procurement processes. Let's talk about transaction management. One of the most compelling reasons to use the Spring Framework is the comprehensive transaction support. The Spring Framework provides a consistent abstraction for transaction management. The Spring Framework delivers the following benefits: provides a consistent programming model across different transaction APIs such as JTA, JDBC, Hibernate, JPA, and JDO. Supports declarative transaction management, provides a simpler API for programmatic transaction management than a number of complex transaction APIs such as JTA. Integrates very well with Spring's various data access abstractions. The first section, entitled Motivations, describes why one would want to use the Spring Framework's transaction abstraction as opposed to EJB CMT or driving transactions via a proprietary API such as Hibernate. The second section, entitled Key Abstractions, outlines the core classes in the Spring Framework's transaction support, as well as how to configure and obtain data source instances from a variety of sources. The third section, entitled Declarative Transaction Management, covers the Spring Framework's support for declarative transaction management. The fourth section, entitled Programmatic Transaction Management, covers the Spring Framework's support for programmatic, that is, explicitly coded transaction management. Traditionally, J2EE developers have had two choices for transaction management: global or local transactions. Global transactions are managed by the application server using the Java Transaction API, JTA. Local transactions are resource specific. The most common example would be a transaction associated with a JDBC connection. Global transactions. Global transactions have a significant downside in that code needs to use JTA, and JTA is a cumbersome API to use, partly due to its exception model. Furthermore, a JTA user transaction normally needs to be sourced from JNDI, meaning that we need to use both JNDI and JTA to use JTA. Obviously, all use of global transactions limits the reusability of application code, as JTA is normally only available in an application server environment. Local transactions. Local transactions may be easier to use but have significant disadvantages. They cannot work across multiple transactional resources. For example, code that manages transactions using a JDBC connection cannot run without a global JTA transaction. Another downside is that local transactions tend to be invasive to the programming model. The transaction definition interface specifies isolation, the degree of isolation this transaction has from the work of other transactions. For example, can this transaction see uncommitted writes from other transactions? Propagation. Normally, all code executed within a transaction scope will run in that transaction. However, there are several options specifying behavior if a transactional method is executed when a transactional context already exists. For example, simply continue running in the existing transaction, the common case, or suspending the existing transaction and creating a new transaction. Spring offers the entire transaction propagation options familiar from EJB CMT. Timeout. How long this transaction may run before timing out and automatically being rolled back by the underlying transaction infrastructure. Read-only status. A read-only transaction does not modify any data. Read-only transactions can be a useful optimization in some cases, such as when using Hibernate. Let's discuss the future of IT. There's a general anxiety that has settled over much of the IT profession in recent years. It is a stark contrast to the situation just over a decade ago. At the end of the 1990s, IT pros were the belles of the ball. The IT labor shortage regularly made headlines, and IT pros were able to command excellent salaries by getting training and certification, job hopping, and in many cases being the only qualified candidate for a key position in a thinly stretched job market. At the time, IT was held up as one of the professions of the future, where more and more of the best jobs would be migrating as computer automated processes replaced manual ones. Unfortunately, that idea of the future has disappeared, or at least morphed into something much different. Now, in the end, let us summarize what we have learnt in this lecture. Information is the driver that serves as the glue to create a coordinated supply chain. Information must have the following characteristics to be useful. The data regarding the a priori constructs was gathered as follows. As for the types of IT used in the case companies, the respondents were asked to describe each of their IT systems used for SCM purposes as well as discuss the activities performed with them. Customer relationship management may be defined as a decision support system that is targeted to helping senior executives, marketing, sales and customer support personnel to better understand and capitalize upon their customer needs, the company's interactions with the customer. Most IT departments are a shadow of their former selves. They have drastically reduced the number of tech support professionals or outsourced the help desk entirely. There are several options specifying behavior if a transactional method is executed when a transaction context already exists. For example, simply continue running in the existing transaction.